To do division with polynomials, we're just going to divide the denominator into each term that we have in our numerator. So for this first problem, the 16w squared will get divided by 8. The 40w will get divided by 8. And the 24 will also get divided by 8. And we reduce the fractions here the same way that we did back before fractions had letters in them. So this 16 and 8 can reduce to a 2 and a 1. This 40 and 8 can reduce to a 5 and a 1. And this 24 and 8 can reduce to a 3 and a 1. So our whole denominator went away since each of our terms was divisible by 8, leaving us with 2w squared minus 5w plus 3. Notice that the signs stay and the variable parts also stay. Now to do this next problem, we've got an r in our denominator as well, but we're still going to set each of these terms up as a separate fraction. So we'll have 21r cubed getting divided by 7r plus a 56r squared divided by 7r and a 7r divided by 7r. So looking at what we can reduce again, the 21 sevenths will become 3 one-ths, 56 sevenths will become 8 one-ths, and 7 sevenths reduces to 1 one-ths. This is where it starts to look a little different from the fractions we've seen in the past, because we also have some r's that we can reduce here. So this is 1r in each one of these cases. If I have 1r on the bottom and 3 on the top, getting rid of this r will reduce this exponent to a 2, because r cubed divided by r is just r squared. So our new first term is going to be 3r, the 3 from here, r squared. Here I have an r squared divided by an r. So this r will go away again, and this squared will go away because 2 minus 1 is just 1r remaining. So this will leave us with a plus 8r. And in our last term, an r divided by an r also reduces down to just 1. So our final term in this answer is 1. Do make sure that when you have 7r over 7r that it doesn't turn into a 0. Because remember, any fraction where the top and the bottom is the same reduces to 1, not to 0. In this last problem, we're going to do a little rearranging before we do the math, because if you look at the exponents here, we have an h squared in our first term, an h to the 0, because there are no h's, in our second term, an h cubed here, and an h to the 1 here. So I want to rearrange this so that I have my polynomial written in standard form, which would be descending order of exponents. So I'm going to make this a 60h cubed. The 36h squared is positive, so it's going to be a 36h squared. My 7h is negative, so it'll be minus 7h, and then minus an 8. And each one of these terms is getting divided by 12h squared. So I'll go ahead and write the 12h squared underneath each term. Reducing my coefficients is going to be the same as it's been in all of the other two problems that we did. So a 12 fits into 60 5 times, and 12 will go into 36 3 times. This 7/12 doesn't reduce, so I'll just leave that alone. And my 8/12, I can take a 4 out of both of those, leaving me with a 2 and a 3. Now the h's here get just a little trickier. Here we have 3 on the top and 2 on the bottom, so 3 minus 2 is going to have all the h's on the bottom disappearing and 2 of the h's on top disappearing, leaving us with just a single h. So my first term becomes 5h. In the second term, h squared over h squared, all the h's will cancel out. So all I have left is the 3. In my next term, there's one h on the top and 2 h's on the bottom. So in this case, my top h's are going to disappear, but I'll still have one h in the bottom. So I'm going to write this next term as a 7 over 12h, because that remaining h is in my denominator, not in my numerator. And for the final term, I don't have any h's on the top, so both of those h's will remain in the bottom, making my final term a 2 over 3 h squared.